Hello from your friends at Parking Pals. We're happy to have you with us today. We are a team made up of Georgia Tech mechanical engineering students. We're working with our sponsors at Delta Airlines to create a solution to an issue that has been plaguing them. To give you a little background, we'll start with the question, what is chocking? Chocking is the process of placing a physical block against the tires of a vehicle, particularly an aircraft, to prevent movement. In the context of our problem, we focus on the human factor of this process, asking ourselves, how can we ensure that chocking is done every time an aircraft is brought to the gate? It's important that chocks are placed at the aircraft wheels for the duration of the time that the aircraft is at the gate. If chocks are not placed, the aircraft's parking brake must be engaged. This is not desirable as it adds extra wear and heating to the brakes. Parking brakes must be below a certain temperature to operate optimally, so excessive heating of the brakes causes a need to wait for them to cool down, leading to delays which cascade throughout the day. Therefore, it's in the interest of the folks at Delta to ensure chocks are always placed to decrease wait times and costs associated with brake heating or part failure. Our team has designed a solution which addresses this issue at its root. By providing notification to crew members on chock placement status, validating chock placement, and tracking chock placement rates, our Parking Pals team hopes to solve this issue that Delta deals with day in and day out. When designing a solution that primarily improves the rate of chock placement among Delta's ground crew members, a unique situation was presented. We had to design a solution that did not interfere with Delta's tarmac or aircraft infrastructure, that adapted to all aircraft wheel sizes within Delta's fleet, that must be visible to aircrew and ground crew members in all operating conditions, as well as maintains its structural and operational integrity by withstanding Delta's dynamic tarmac environment. Additionally, our solution was required to meet the chocking specifications detailed within the MILPERF 3258A and SAE Air 4905 that describe performance and manufacturing specifications of chocks, as well as the RAMP LOSA documentation provided by the Federal Aviation Administration, which describes a standardized chocking procedure that must be adhered to by ground crew members. Despite the unique set of system constraints, the Parking Pals were up to the challenge. We have designed a two-part multifunctional system solution that avoids a culmination of $6 million in costs associated with engaging aircraft parking brakes. The first part is a smart chock system which utilizes a transceiver module embedded in the chocks. This allows for the measurement of the relative positions of chocks close to one another. These modules can communicate wirelessly by broadcasting and receiving unique identification codes when an action is performed. This is coupled with a pressure sensor system which allows the chock to identify that it has been placed. Once a chock is placed correctly, it sends out a signal indicating the action has been performed. Placed chocks listen for signals from other chocks, and once they detect that 3 pairs of chocks have been placed, they will emit a complete circuit signal. This complete circuit signal will be relayed to a central computer located in the second part of our solution, the chocking cart, also known as the chock stop. Located at each Delta gate, the chock stop structure will house 10 chock pairs while chocks are not in use. A central processing unit will be housed within the chock stop structure to control the sensors and manage logic. The central computer takes in the signals from the chocks and checks their position against the configuration expected. An LED alarm system will be implemented into this design to notify ground crew members when chocking needs to be performed and indicate to them if it has been completed. If all chocks are placed and done in the correct fashion, the LED indicating chock placement flips to green, indicating success. The shelves of this structure house wireless chargers which will be used to charge the smart chocks. The wireless charging doubles as a presence sensor, indicating when chocks are present in the cubby. The proposed two-part solution consisting of a smart chock and a shelving system that holds chock pairs will greatly benefit Delta Airlines. To start, the system gives Delta a dedicated space to store chocks for use at gates. In its current state, chocks are strewn about the gate and have to be located and picked up each time an aircraft comes into park. With the proposed chocking cart, the grounds crew not only know where to get chocks, they know where to put them back too. On top of this, the sensors in the chocks allow tracking of each chock's location at all times, allowing crews to locate and keep track of all chocks to ensure that they stay where they are needed. The smart chock system additionally allows tracking of chock placement or compliance as a metric to be used by Delta to ensure proper countermeasures are taken to ensure this is always occurring. Lastly, the proposed solution addresses the central issue by communicating to grounds crew when chocks are placed and when they are not. This ensures that grounds crew are notified if they need to perform their duties and can also ensure that chocks are placed in the correct configuration and that they are not jostled out of position. In this manner, our proposed solution attacks Delta's central issue at its root and expands Delta's ability to ensure it never becomes a problem again. Many have tried to figure this problem out, but we are the team to solve it for good. Thank you for your time, and welcome to a world where chocks are always placed.